Okay, Assalamualaikum warahmatullahi wabarakatuh and a very good afternoon everyone. So kita akan, we will see exercise 3.4 for today and 3.5, okay, which is the implicit as well as the extrema, okay. So exercise 3.4, the implicit partial derivative. Find del z del x and del z del y if, question number 1, 3x squared plus 5y squared plus 4z squared to the power 3 over 2 equals to 7. Okay, so the question asks you to find del z del x. You can strictly use the formula, in which is to find del z del x. The formula is negative fx over fz, right? Which is negative. The fx means you differentiate your variable, your function with respect to x, keeping all other variables as constant. So you have three variables here, x, y, and z. If you are differentiating with respect to x, means your y and z are constants. Before that, you have to leave your equation, this equation, in terms of fxy z equals to 0. So I have to bring this 7 to the other side, okay? Okay, you have your x here. Okay, your y and z is constant, but before you differentiating your x, you have to differentiate the power 3 over 2, okay? So you have 3 over 2 and then the minus 7 will be minus 0, okay? Divided by, now differentiate with respect to z. But again, before differentiating the z, we have to differentiate the power first. So it will be exact. So it can cancel out this one also, everything can cancel out. So what's left is negative 6x over exact. Del y means a negative fy over fz, okay? So again, we're using formulas only. So differentiate with respect to y, keeping all others as constants. Before that, you differentiate the power first. Y means 10y. Okay, this one we have already done in the first step. So this one can cancel out, this everything can cancel out as well. So what's left is 10y over x. Okay, so remember, before you are differentiating whatever in the bracket, okay, you have to differentiate outside the bracket first, which is the power. Okay, let's move into question number 2. Okay, find del z del x and del z del y. Now we have ln. Ln 4y squared minus 3x plus 2z to the power of 3 equals to 5x. Okay, so remember, if you want to use the formula, so again you have to rearrange the equation so that your right hand side is equals to 0 only. Then this is your f, x, y, z. So So to find del z del x, it is actually to find negative fx over fz. Okay, so the variable in denominator should be in the numerator and vice versa lah. Okay, when you do like this, okay, you don't have to focus on the implicit. Okay, it will become a normal partial derivative. Normal partial derivative means when you differentiate of one variable, now you want to differentiate x, differentiate with respect to x, so all other variables will be constant, which is y and z become constant. Ini pun sama, saya differentiate with respect to z, okay, so my x and y will be constant. Okay, but then if you don't do like this, you do the implicit differentiation, okay, means strictly differentiate, you have to bear in mind that your z now is an implicit function in terms of x and y. Okay, so yang itu you kena tengok implicit tu macam mana nak bezakan dia. Okay, dia bukan jadi normal partial derivative dah lah. So let's just find fx. So we have x here in the 3x. Okay, so before we are differentiating the 3x, we have to differentiate ln. You differentiate ln, you will get 1 over. Now we are differentiating z. So it will be 6z squared. The x and y constant. The 5x also constant. So this is your answer for del z del x. Or you can get the simplify the answer as yang ni kena darab lah. Ni darab ni. Okay. And then ni actually boleh potong bawah. Cuma yang ini sebelum nak potong kena darabkan juga. Okay. So you'll get negative, negative will be positive. Negative, negative will be positive again. It's this one. Now let's go into del z del y, which is y now. Okay, fy and fz. So yang ini dia senang, tapi yang nak darab 5 ni, macam ni kena darab 5 kan, sebab kita nak potong atas bawah. Okay. So yang ni tak payah sebab dia tak ada tambah tolak lagi, dia boleh potong straight lah. So you get negative 8y over 6z squared. Okay, so again, first step must be minus 3 equals to 0. Minus, you have to make your right hand side equals to 0. The equation of the right hand side of your equation equals to 0. Then the rest just a repeated process. Okay, now you want to differentiate with respect to x. Your z here now is a constant. So tulis je siap-siap. So dia hanyalah constant. Okay, your x is here in the cos. Okay, before you differentiate the x, you have to differentiate the cos. Differentiate cos dapatlah negative sign. And then you multiply, then you differentiate the x, y, z. Okay, now you want to differentiate with respect to x. So your y, z is a constant. Okay, the minus 3 is constant as well, so equals to 0. Okay, you repeat the same process now with respect to, you want to differentiate respect to z. So the x squared will be a constant, so it's become 0. Okay, so the second equation, the second term, you have z here, and then you have cos z, which is two different functions. The first z is a polynomial to the power of 1. The second z, the second variable, is a trigonometric function in which it is cos, right? Cos x, y, z. So you have to do a product rule for fz. Okay. So whenever you come across a multiplication of two different functions, okay, either it is polynomial or with exponent, polynomial with trigo with exponent, polynomial with ln, and so on, okay, you have to use product rule to differentiate the function. So u v prime plus v u prime. So I differentiate z first, I will have 1 plus, then I differentiate cos, I will have negative sign xyz, and then multiply with differentiate the xyz with respect to z. So now the xy is a constant. Okay, so you have something like this. So you may simplify the answer. This is negative. Okay, you boleh darab lah. Negatif ni you boleh darab ke atas atau ke bawah, tapi salah satu saja, either one. Okay, do not multiply both to the numerator and to the denominator. Okay, only either one. Sebab dia negatif ni cuma bawa satu arah saja. Okay, this one, the yz, you kena darab ke depan multiply to the front. Do not here. Okay, this one as well. No, do not multiply here. Okay, so you have yz squared, negative, negative, positive. One negative, negative, positive, tolak positif. So yz minus 2x over cos x, yz, negative, positive, negative, x, yz again, sin x, yz. Okay, so you get your answer is this one. Now you repeat the process of finding fy over fz. Del z, del y now. Okay. So again, if you want to find fy, your x squared is a constant, so it's become 0. The z also constant. Okay. Differentiate cos will get sine, negative sine. Multiply, differentiate x, y, z with respect to y, we will have x, z. Okay, negative 3 is only constant, so it becomes 0. Divided by, okay, we have already find the fz. Okay. So, you boleh ambil saja jawapan awak daripada atas tu lah. Sebab jawapan dia yang sama. Fz ni sama saja. Okay, so remember this one to be multiplied to the front. Negative, negative dapatlah positif. Okay, so this is your answer. Okay, proceed with question number 4. Find the slope of the sphere in the x direction and y direction. Find the slope of the sphere x squared plus y squared plus z squared equals to 9 over 25. In the x direction means del z del x. In the y direction means del z del y. So since z here is an implicit function of x and y, okay, so we can use the formula. Okay, to differentiate with respect to fx, your x only, you differentiate x only, then the y squared is 0, the z squared also 0, okay, because it is a constant. Oh, before that, again, x squared plus y squared plus z squared minus 9 over 25 equals to 0. You have to leave your equation the right hand side of the equation equals to 0. Okay, make it a habit. So kalau you terlupa and then happens that sebelah kanan tu ada satu variable. So variable tu pun awak akan terlupa untuk bezakan nanti. Tapi kalau contoh macam ni, dia kebetulan bukan variable, it is a constant. So awak selamat lah. Okay, sebab bila nak bezakan constant memang dapat kosong. Tetapi if it's not a constant, if it's a variable, then you forget to do like this, okay? Then you forget to differentiate the variable, then the answer will be wrong lah, okay? With respect to z, I will have 2z. Sorry. Okay, I will have 2z or negative x over z. Then the question give x equals to 2 over 5, y equals to 1 over 5, z equals to negative 2 over 5. So it will be negative 2 over 5 over negative 2 over 5, which is 1. Negative 2, negative, positive, so you get 1 over 2. Okay, so that's it for implicit partial differentiation. Okay, I hope you already you can differentiate what is implicit and what is not implicit partial differentiation. Okay, if you have, if let's say you want to differentiate z and your equation is in terms of z only, z equals to x squared plus y squared. So this is explicit, okay, because you can directly differentiate z with respect to x and directly differentiate z with respect to y. However, if your z is now not in terms of z, let's say you have z squared equals to x squared plus y squared. This is what we call implicit. Okay, because if you want to find del z del x, you have to differentiate your z also to z del x. Okay, and then equals to 2x plus 0. Then you can find your del z del x equals to 2x over 2z. This is what we call implicit. Okay, other than z, let's say you have ln z equals to x squared plus y squared. It is also implicit because your z function now is in terms of another function. Ln or exponent z equals to x squared plus y squared. Now you want to differentiate z with respect to x, okay? But before you differentiate z with respect to x, you have to differentiate the exponent, okay? Which is will have exponent z as well. And then implicitly you have to multiply del z del x. Then you have 2x. Okay, then this is your answer. Okay, you bring whatever function or equation attached to del z del x to right hand side. Okay, because the answer must be in terms of del z del x or del z del y only. Okay, you can use like this or you can use formula. Let's say del z del x means negative fx over fz. Okay, if I try to do this one, if I use a formula, means I have to rearrange my equation to be z squared minus x squared minus y squared equals to 0. Okay, you have to make your right hand side of the equation equals to 0. Then fx is actually negative 2x. Okay, you just differentiate from here. Okay, when you want to differentiate with respect to x, leaving all other variables as constant. Then fz is 2z. Okay, so you directly get your answer, which is x over z. Same as this one, implicitly. Okay, this one I differentiate implicitly. This one I use formula. Okay, then we will go to 3.5, which is our final topic in this chapter. 3.5 is Extrema. Okay, 3.5 is not included in your quiz. Okay, however, it will be in your assignment as well as final. Okay, quiz sampai 3.4 saja yang tadi tu Locate all relative extrema and saddle points if any. Okay, first of all, you find fx and fy equal to 0. Okay, means first step is to find the critical point. So when you want to find fx, means you differentiate with respect to x, leaving all other variables as constant. So 2y is 0, 5 also 0. Okay, and then the other 0, so equals to 0. Okay, you equate your fx equals to 0 and your fy equals to 0 to find critical points. So this is your first equation, this is your second equation. Actually, from second equation, we can directly get our points of x, which is x equals to -2. So substitute 3 into 1. So y will be equals to 0. So I only have one critical point, which is -2, 0. So second is to test this critical point. Okay, test critical point. You have to test the critical point. You have to find fxx, fyy, and fxy because we want to use the second derivative test. Okay. Okay, differentiate again our fx with respect to x again. So here we'll have 2. Okay, fyy is to differentiate y again respect to y. So dah tak ada y kat situ kan, so dapatlah kosong. fxy pun sama. fxy is actually equals to fyx which is equals to 1. Okay, so you just use the formula. This formula is given. Okay, kita perlu hafal lah. So fxx times fyy minus fxy squared, which is 2 times 0 minus 1 squared, which is -1. So negative is less than 0. So when your d is negative or less than 0, you have a saddle point. So we say we have a saddle point at -2, 0. Okay. This is the step, and then you repeat again the step for question number 2, 3, and 4. Okay, the test theorem is not given, only the D. Okay, the formula for D is only given. Yang ini saja. So yang D tu dapat lebih besar dapat apa, lebih kecil dapat apa, itu so you kena tahulah. Okay. So again, I want to differentiate with respect to x. My 3y squared will be 0. The -2xy will be -2y. Okay, because y is constant. And then the x squared will be 2x minus 8 equals to 0. Then the fy, x squared is constant 0, -8x is constant also 0. Okay, so define your y. So you have your critical point. So actually in this part, you can do anything you like, as long as it makes sense, because in this part you have to do the simultaneous equation. You have to solve the simultaneous equation. Okay, you may start from equation 1 or equation 2 or vice versa. Okay. Okay, so your d is greater than 0. So if it's greater than 0, you have to look into your fxx. Because greater than 0, you have two situation, okay? Either your fxx greater than 0 or less than 0. So our fxx is equals to 2, which is greater than 0. So kita akan ada minimum. Okay, remember, for greater than 0, you have to look into your fxx. Either it's greater also or less. Okay, so this is minimum, this is maximum. Okay, now your fxy is equals to 4xy minus x to the power 4 minus y to the power of 4. Okay. Okay, both equals to 0. Then this is your first equation, this is your second equation. Okay, then you have y equals to x to the power of 3 from first equation. Substitute into 2. Y is x to the power of 3, 2 power of 3 again, equals to 0. So 4x minus x to the power of 9 now. Okay, so if I factorize that 4x, I will have 4x what's left is only x to the power of 8. Okay. So I have 4x equals to 0, and then the other one is 1 minus x to the power of 8 equals to 0. So this one yield x equals to 0, and this one yield x to the power of 8 equals to 1, which is x equals to plus minus 1. Because this is even power, so when you find the root for even power, you will have a plus minus. Okay. So you have 3 points here. If x equals to 0, then your y equals to x to the power of 3, right? Which is 0, 0 also. So you have 0, 0. So you have 1, 1. Then you have negative 1, negative 1. So you have 3 points, 3 critical points. This is your critical points. Now you want to test each of your critical points. Okay, kalau you ada 10 critical point, you have to test 10 tu. Okay, jangan tinggal salah satu. So before you find D, let's find fxx and fyy and fxy. So fxx is 12x squared. Fyy is negative 12. So you have negative there. Okay. Suppose have negative, fxy is 4, fyx also 4. Okay, so now you want to test each critical point. So D0, 0 means your x is 0, your y also 0. So you have negative 16, which is less than 0. Because they are negative, and so bila negative less than 0 means we will have a saddle point. Okay, then test our second critical point. So we'll have 1, 1. So kepala 144 tolak 16, which is 28 greater than 0. So if it's greater than 0, then you have to look back into your fxx. Because fxx is negative 12x squared kan. Sekarang x kita adalah 1. So negative 12, 1 kuasa 2 dapatlah negative 12 juga. Negative 12 adalah kosong. 1 lebih besar, 1 lebih kecil, then you akan dapat maksimum. So maximum 1, 1. Now last point is negative 1, negative 1. Okay, negative 1 kuasa 2 dapatlah 1, negative 1 kuasa 2 dapatlah 1 juga. So dia punya D akan jadi sama, tapi dia punya fxx negative 1 kuasa 2, negative 12 juga, which is less than 0. So 1 lebih besar, 1 lebih kecil, kita akan ada max. Okay, so just do it one by one. Find the fx equals to 0, fy equals to 0, and then you find your fxx, your fyy, your fxy. Use the second derivative test formula, the D, and then test for each your critical point. So now you have two critical points. The one with y equals to 0 and the other one with y equals to negative 8 over 3. Sorry, 8 over 3 only. Okay. So you use this to find your x. Okay, we have two we have found our two critical points. Now we want to test. Okay, so our first point is 0 minus 16, which is negative 16 less than 0. So again, we have a saddle point. Our second point is a 16 over 3 and 8 over 3. So we substitute the 8 over 3 because the equation only requires y. Okay. So 12 times 8 over 3 minus 16 will have 16 also. Okay, which is greater than 0. So whenever it's greater than 0, you have to look into your fxx. So you have negative 2, which is less than 0. So one is greater, one is less, then you have a maximum. Okay. Last question. Okay, so now you have two different function. Yeah, it's a multiplication. So you can either open the bracket, means expand, okay, darab lah, ataupun you boleh buat product rule. You tak perlu nak open the bracket, you stick to u. This is your u, this is your v. Okay. Okay. So for the first one, sebab dia ada 4x kan. So ini ada 2x. So saya jadikan ini 2x. So 2 tu saya darab ke depan sini. Okay, so dia akan jadi like this one. Okay, and then bila dah dapat macam tu, saya boleh faktorkan 2x dengan 2x ni. Okay, then I will have something like this. This is actually plus. Sorry. Okay, so I have 2x equals to 0, and the other one is 2x squared xy plus x squared plus 1 to 0. This one is equals to 0 already. So this one will be 3y equals to 0 and y equals to 0 as well. So you have 0, 0 as your critical point. Okay, sama juga kalau ambil nombor 2 ni pun. Buka kurungan x kuasa 2 tambah y tambah 2x kuasa 2 tambah y equals to 0. So 3x squared plus y equals to 0. Since x is already equals to 0, so y also equals to 0. Betul lah, okay? So you only have one critical point. Satu tambah x kuasa 2 tambah 1. Okay. So it will be 0. Okay, so when your d is equals to 0, because you have now d 0, 0, your x is 0, your y is 0, when you substitute the value, it will become 0. Then no conclusion can be drawn. Means it is we don't know it's either saddle point, maximum or minimum. So there are more tests needed to be done. Okay, if you have heard about first derivative test, that one can be used to determine this kind of question lah, yang tak dapat nak selesaikan guna second derivative, kita akan gunakan first derivative. But then you didn't learn the first derivative in this topic. Okay, you only learn the second derivative. So you have to know it is when it is greater than 0, less than 0, and equals to 0, what it means. Okay. So we have finished the extrema as well for today. So I'm not looking to go into tutorial right now, so you may answer the tutorial yourself first. Okay, and as usual, if you don't know how to answer, you may WhatsApp me. Okay, I feel like I'm talking alone right now. Okay, I hope you understand whatever I do the examples here. Okay, so if you don't, please do not hesitate to contact me. Okay, through WhatsApp. Okay, thank you everyone. So please proceed, do the tutorial 3 and WhatsApp me if you have problem. Okay.